Hello. In today's lesson, we're going to be taking a look at inverse trig functions. Now, what inverse trig functions solve for are different angles or radians. Now, remember your unit circle lesson where, let's say, you were asked to find the sine of 45 degrees. So we know that we could look at our unit circle, go to 45 degrees, look at the y value, and we would get square root of 2 over 2. Now in today's lesson, what you're going to be given is something that would look like find what degree would you get for sine of what angle equals root 2 over 2. So we know that that angle would be 45 degrees or that radian would be pi over 4. Now, keep in mind with your unit circle, a lot of times you have two possible values, but we'll take a look at that as we kind of go. So to start off, something we're going to be using a lot in this lesson, a circle with a radius of 1 unit is called a unit circle. Okay, second one. What is sine of 30 degrees? So if you don't remember that, realize 30 degrees would be kind of your first, it's a bad picture, would be your first kind of first angle on the unit circle. Now, am I going to be closer to my x values being cut in half or my y values being cut in half? Now, even though I didn't make a very good picture, we can tell that the y value is going to be cut in half. So we should know that the sine of 30 degrees is equal to 1/2. Then what is the cosine of pi over 4? If you don't know what pi over 4 is, this is what the one I was talking about at the beginning of the lesson. Pi over 4 is the same as 45 degrees. We know that any of our 45s all have the same value of root 2 over 2. Just a matter of what quadrant that is in and what value it's asking for. Pi over 4 is in quadrant 1, so everything would be positive. Okay? All right. Evaluation of trigonometric functions for given angle measures was explained in lesson 46. Angle measures that have given trigonometric function values can be found by using inverse trigonometric relations. So if we have sine of x is equal to a, then the sine inverse of a would give us x. So like I said before, what we are solving for is the angle by using the inverse trig function. The inverses of the trig functions are not functions themselves because there are many values of x for a particular value of a. So what that means is that because our unit circle would go on continuously as long as you add a 360 degrees or a 2 pi, the inverse trig functions are not actually functions. They would just be relations. So describe all the values of sine inverse of pi or root 3 over 2. So if you look at the unit circle over to the right, you can see that pi over 3 has a y value of root 3 over 2, and the 2 root 3 over 2, or 2 pi over 3 also has root 3 over 2 as a sine. So if we're describing all of the values, then for that first answer, we would have pi over 3, and I'm going to say theta because we're talking about some angle measure, plus 2 pi times n, or x, or something like that. Because if I add 2 pi on there, I'm going to get the same value. And likewise, my second solution for this would be 2 pi over 3 plus 2 pi n. So if it was 0, then it would just be, if n was 0, then it would just be that pi over 3 or 2 pi over 3. If n was 1, then we would just be going around the unit circle. So let's say, here's my first answer. If I added a 2 pi, then I'd be going all the way around, and then I'd be there again, so I'd have the same value. That's kind of what we're getting at by adding 2 pi times n If you added n equals 2, then you'd be going around twice and then landing at that same value, so on and so forth. Okay. To define inverse trigonometric functions, it is necessary to restrict the domains. Okay, so we're switching from relations to functions now. So it is necessary to restrict the domains and the domains of the trigonometric functions. The trigonometric functions that a calculator uses have restricted domains and will give only one value in the range that you will need to generalize to find all the possible values. So for sine, they will give you anything from negative 90 degrees to 90 degrees. So we're looking at any of these values. For cosine, they're giving you anywhere from 0 to pi or 0 to 180 degrees. And for tangent, again, not including. You can see those other two are including. But tangent, we have negative 90 is less than x is less than 90. The reason why those aren't included is because at negative 90 and at 90, the tangent is undefined. Okay? Sine of x, cosine of x, and tangent of x can be used to define inverse trig functions. For each value of a in the domain of any inverse trig function, there is one and only one value of x in the range. So if you guys didn't know this already, sine of x has a range that goes from -1 to 1, along with cosine. So that means because we're dealing with an inverse, both of those are going to have a domain that go from -1 to 1. Now, we know that those are infinite, but because, again, in order to make it a function, we have to restrict those domains. Now the range gets restricted for the inverse. So we're just looking at those values that we were looking at before. So sine from negative 90 to 90, or in radians, negative pi over 2 to pi over 2. For cosine, the range would be from 0 to pi or 0 to 180, and inverse tangent would be negative 90 to 90. And again, that should be not included. So that should just be negative 90 is less than x is less than 90. Negative pi over 2 is less than x is less than pi over 2. So let's take a look at this. Find each inverse trig function value that exists. Give an answer in both radians and degrees. So tangent, where is tangent equal to -1? So I have to look at my range of tangent and realize that I'm just looking at from negative 90 to 90. So any value that I come up with has to be between here and here. So if I'm thinking what gives me a negative value, that's going to be in that quadrant 4. So that's going to be, I know that -1, I'm thinking, where are the x and the y values the same? Well, that's going to be dealing with root 2 over 2 and a root 2 over 2. Okay? Now that would be a 1 because tangent, remember, tangent of theta is equal to y over x. So it would be root 2 over 2 divided by root 2 over 2. Now one of them has to be negative, so we're going to be looking at the lower quadrant. So because this is at pi over 4 or 45 degrees, then the negative one is going to be at negative pi over 4 or negative 45 degrees. The second one, or part B, cosine inverse of 2 is equal to what? Now let's go back again, look at our cosine values. Now our cosine domain, our a values have to be in between -1 and 1. So that means if I'm asked for the cosine of 2, that does not exist because it's outside of my domain. So that's all we're doing there. Now if we're solving trig functions, you can see we're given solve 2 times cosine of x is equal to square root of 3 for any value between 0 and 360 degrees. So with that trig function, I want to be left with only that. I want to be left with only cosine of x for part A. So in order to do that, I'm going to have to divide by 2. So where is cosine equal to square root of 3 over 2? That's what we're asking now. Now, algebraically, in order to actually get that x by itself, I would do the cosine inverse of both sides. So if I do the cosine inverse of the cosine function, that actually cancels all of that out. And I have x is equal to the cosine inverse of square root of 3 over 2. And that is simply just what are my two values, essentially. So at x equals 30 degrees and x equals 330 degrees are two values where cosine inverse, or the only two values where cosine inverse is equal to root 3 over 2. And I know that just from working with the unit circle and different things that I know about the unit circle. So it's all about just making sure that you have those values memorized and you know generally where things go. Let's look at part B. Again, we just want sine of x all by itself, so I would divide by 5. So we have sine of x equals 1. In order to get rid of the sine, we would do the sine inverse from both sides. So x is equal to the sine inverse of 1. Now there's only going to be one value that gives you, there's only 1 degree or radian where your x value, or where sine has a value of 1. That's going to be at 90 degrees. If we go straight up to the top, our cosine is 0, our sine is 1. Anywhere else, that value would be a negative. So if we went down to 270, that would be a negative 1, so that wouldn't work. So x is equal to 90 degrees. Then the last one, it's going to take a little bit more solving. That's okay. Subtract 3, subtract 3. And then we would divide by 6 and simplify. So we have sine of x equals negative 1/2. Again, we would do sine inverse of both sides because I'm dealing with a negative sine value. I know I'm going to be on the quadrant 3 and 4. Now, my sine values, or my degrees, would be at, let's see, it's going to be down here, and that would be down here. So 180 plus, that'd be 210, which would be, we want it in radians. So sine of, that would be 7 pi over 6 is equal to negative 1/2. And that would be at 330, which is 11 pi over 6 equals negative 1/2. So those are the two values that are your answer here. So x equals 7 pi over 6 and 11 pi over 6. And if you're not comfortable with radians, then you can always just find those in degrees, and then you can multiply them by pi over 180 to get that radian number. All right, now if we're going to be solving these with a calculator, the first thing that we want to do is make sure that that calculator is in degree mode, since our restriction is given in degrees. And then what I'm going to do is, just like our last problems, I need to come up with my trig function all by itself. So I'm going to divide by 10 on both sides. That's going to give me cosine of x is equal to, I'm going to reduce that to 3/5. Then both sides, I would take the cosine inverse. Now, grab a calculator. So I'm going to do, you can see cosine is right here, right behind it in blue is cosine inverse. So I'm going to do second cosine. 3/5 or is the same as 0.6. And I get 53.1. If you don't get that, then you need to check your mode. So you can see right here you have radian or degree mode. Since that restriction is in degrees, then we need to have it in degree mode. So 53.1, they wanted it to the nearest tenth. So x equals 53.1 degrees. And then the next one, we want those same function, but between 270 and 360. So what I do there is I take 360 minus 53.1. So 306.9 degrees. Okay. Last problem here. A pair of hikers plan to walk from a campground to a waterfall. The waterfall is 2.5 miles. The waterfall is 2.5 miles east, and 0.5 miles north of the campground. Spelling error in there. 0.5 miles north of the campground to the nearest degree. In what direction should they head? So here's our campground, 2.5 miles and 0.5 north. So we want to know what this degree would be. So I would have an opposite over adjacent. So that's going to be tangent of theta is equal to 0.5 over 2.5. which is 1/5 or 0.2. So tangent theta is equal to 0.2. So then the tangent inverse of 0.2 is going to give us what? So I'm going to go back to our calculator. We're going to hit second tangent, 0.2 or 2/10. That's going to give us 11.3 degrees. So again, I figured out what my trig relationship would be between those two values, and then you take the tangent, or you take the inverse trig function in order to find the angle. So 11.3 degrees. I hope this was beneficial for you guys, hopefully a little bit easier than the last lesson we did. But if you need to watch anything that looked hard, watch it a second time, slow it down, try it on your own and follow along. Hope you guys have a great day. Thank you.